Welcome to our Fabric Fast program. FAST standing for Fabric at Scale Together. Fabric Fast is a program built by the Microsoft Global Partner Solutions org to help our partners ramp up on Microsoft Fabric. Now, although we designed this content for our channel partners in mind, we are placing this content online, not just for our channel partners, but for everybody, allowing you to find the content that's most useful for you. In this session, Chris Mitchell gives us a lap around Microsoft Fabric with a little bit of real-time intelligence sprinkled in that creates a fun demonstration. This session lays the foundation for our future sessions that dive into data warehousing, further exploring real-time intelligence, and building semantic models. So here's Chris.
Thanks, Brian. I just switched over to me being the presenter mode. Can somebody give me a thumbs up or a yes that you can see my slides now?
I have it. Looks
Perfect.
good.
Alrighty. Well, here's a quick agenda, but I don't like spending a lot of time talking about agendas, and you can see this is pretty basic. We're just going to do an overview. We're going to talk a little bit about what some of these interesting business scenarios Fabric enables, and then we'll jump straight into a demo. So to start off, I thought I'd start with this slide, which I believe May showed last week for those of you that are with us. And the key point here is not to scare anyone, but just to speak to the fact that the analytics and AI landscape is gigantic. And many of the customers and partners we work with find getting started a very daunting task because there are so many technologies and products to choose from. And many times you'll go through a scenario where it's figuring out how to creatively weave 3 or 4 different products that aren't necessarily designed to work together into a complete and cohesive solution. And that many times, adds a lot of complexity. It requires a lot of people with specialized experiences and trying to figure out the integration points and how they connect and collaborate and work together. You end up with architectures that, kind of look fairly gnarly and complicated like this. And, we just got a few examples. And you can see there's all sorts of different considerations and concerns about source data systems, where the data comes from, how it moves through the system, how it's stored and aggregated, and ultimately viewed in the end. And the point is like we said, analytics is a complicated business problem. And this is where, the genesis of Fabric comes from. If you've spent some time in the Microsoft ecosystem working on our analytics platform, Power BI is a very large part of that, but we had other tools available as well, like Azure Data Factory and Synapse and Azure Data Explorer and the like. And while there were some benefits there because they were all built by Microsoft, it was still sometimes difficult to kind of weave all those products together. And really, that's where Fabric comes in, right? What we're trying to do is build and offer a complete unified analytics platform. The intent is getting our customers and partners in an arena where the tools feel like they belong together because they are a single tool set. You have everything you need in order to build a complete analytics solution. However, we also don't want a closed-off ecosystem, and the reason that's important is because we want to encourage interoperability with ISV partners and SI partners and other third parties that want to both get value out of the Fabric ecosystem, but also add value into the Fabric ecosystem. And a key part of this is this lake-centric open concept we have. So all the storage underneath of Fabric is using standard protocols. It's using standard data type formats. So there's nothing really proprietary in our underlying storage. And so that makes it really easy and seamless for third parties to feed data into Fabric for consumption and then also query data out of Fabric if they're not using a Fabric for 100% of their solution. We also realize that there are many constituents that work on an analytics solution. There's many roles, and each user, based on their context and experience and roles, should be able to get value out of Fabric in a way that is tailored to the experiences that they need. And then ultimately, you'd be living under a rock if you hadn't heard about AI. And AI is really kind of becoming central to the mission of every single product at Microsoft. So how do we use AI to enable data engineers to build solutions faster? How do we use AI to enable, business users in order to get insights and value out of the data faster? And so you'll see as we talk about some of the Copilot features later on, Fabric takes that very seriously as well. And so not only do we provide this robust analytics platform, but we're also providing AI features in that platform to help increase productivity and have users gain value out of the solution quicker. Okay, and so a few more concepts I just want to dig into here. Because it is a unified platform and it's a SaaS platform, it's designed to just work out of the gates. It's designed to accelerate user productivity, and I don't need to read all these bullets to you, but it's designed in a number of ways to accelerate user productivity by getting them to a functional solution faster. It's designed to be, work well out of the box without you having to spend all your time tweaking and tuning, indexes and knobs and features in the platform to make it work exactly how you need it to for your solution. And then also because it's a unified platform, it gives you a great ability to administer it in a central way, administer and govern and understand how your solution is being used without having to go and move around to a myriad of different tools to find that information. Okay, so let's dig into what is Fabric. So there's this core pillar, these core top pillars of Fabric that you'll see that are really speaking to different features of the platform that participate in a full analytics solution. Data Factory is the portion of it that is dealing with data engineering and data movement. So the idea is that you're pulling data from a variety of different sources, and you may need to join those sources together, manipulate the data, transform it into an appropriate format, and then store it at a location. And that's what Data Factory is all about. I also realize that I have a couple slides later on, so I don't want to drain the slides. So let me stop myself here, getting ahead of myself, and just talk about the fact that we've got data movement technologies. We've got technologies for dealing with real time. We've got the ability to house databases in Fabric. We have the ability to build specialized analytical models on top of the data in Fabric, industry solutions. So, if you have a specific manufacturing business case or whatever, there will be rich industry solutions and industry data models housed in Fabric that can help you accelerate the time to those solutions. Power BI, as you probably all know, is our data visualization product. And then this wild card over here on the right is, partner solutions. So there are many partners that play in this ecosystem that will extend our platform. A couple great examples of these, if you haven't run into them, are partners like Clued-In and Prophecy, who both add master data management capabilities to our solution that we don't have out of the box. And then, moving down the stack here, Copilot, as we already called out, is out here that is a way to very quickly enable users to get value out of the platform and extend the platform without necessarily having to walk up with all the skills. So you can use Copilot to do things like help you manipulate your analytic model, help you build, data. Data wrangling capabilities, help you do data engineering, and also help you build reports. And so that's a very important feature that you're going to see woven all the way through the Fabric platform. Below that, we have OneLake. So OneLake is our core storage area, and we're going to dig a little bit more into what OneLake is. But the idea is everything in Fabric stores its data in OneLake. And this enables all of these different tools to work off the same set of data. Unlike a traditional analytics platform, which will require you to move data and make copies of it all the time, the idea that everything lives in OneLake should minimize or reduce the amount of time that you have to spend making copies of data. And then obviously down at the bottom here is the Microsoft Purview. I mentioned master data management. So that master data management technology that you see up in the partner solutions area dovetails very nicely with Microsoft Purview, which gives us this, rich data governance platform to do things like build a data glossary and do data lineage and data discovery and other things like that. And so just managing and discovering and governing all the data that lives in this Fabric ecosystem is what Purview does for us. All right, so digging into OneLake, as I said I would, I mentioned we like to jokingly call it's like OneDrive for data, which is funny because OneDrive can store data. But the point here is that this is like an enterprise OneDrive where you can store all your relevant analytics and source data and make it accessible to all these different engines that run inside the Fabric ecosystem. And another way to look at this is that OneLake is the underpinning between all these different universal compute engines that we have. We have all these engines inside of Fabric run on the same shared compute infrastructure, and they all have equal access to that OneLake environment. So for example, you could be using a Spark engine to do data engineering. You could be using a database engine to query and load data. You could be using the Kusto database to do time-oriented work on data. You could use Power BI to do your analytical models, and all these things stored under that OneLake environment. All right. Okay, so let's move on here. So this is what I started to get ahead of myself on earlier, but this is just a little breakdown of the various features. I will do my best to kind of summarize this, but as I was talking about earlier, Data Factory does do that rich data engineering process, and it's got a couple different modalities in which it does this. But the idea is that if you have a workflow or a data process for manipulating your data, this is where it would live. It would live in Data Factory. You could use this to do things like move files. You could use it to execute queries and store procedures in the source database. You could use it to call out to AI models to score your data, do transformation, etc. All this runs under that Data Factory platform. Real-time intelligence is more about collecting and intelligent data streams from sources like an IoT system. You could use this to get really, really granular source data, do things like build time aggregations on that data, custom calculations on that data as the data is streaming through your system, and then build and then use Power BI at the end to build reporting on that. But it's more about dealing with real-time streams of data versus batch-oriented data, which is what you would deal with in a Data Factory environment. So similar mission, but it's working in a different way because we're processing the data as it arrives instead of waiting for a collection of data to do batch processes on. Databases is something that you may not be aware of. It's something that's fairly new. We've added the capability to host Azure SQL databases within the Fabric ecosystem. And I think that this area is going to evolve over time to include a variety of other databases as well, like potentially Cosmos DB. You might see Postgres databases in the future. But the idea is that using that Fabric environment to host other databases beyond your analytical stores is valuable as well. Data engineering, again, data engineering could be processed as part of a Data Factory pipeline, but this goes beyond just like data movement. It gives you the ability to do full, programmatic manipulation of data through a Spark engine. Data warehousing is something that should be very well known. Microsoft's got a heritage of doing rich data warehousing capabilities at scale over very, very large volumes of data. Data science, the ability to host and train and manage AI models and machine learning models can be done within Fabric. I mentioned and talked a little bit about the data science, the industry solutions. And then obviously Power BI and partner solutions, we've already talked a little bit about those as well. So just needless to say, back to front, everything that is in Fabric is designed to handle the end-to-end needs of an analytic platform. And as I mentioned a little bit earlier, we have a bunch of different constituent parties that will work on an analytics solution that have different roles, different focuses, different responsibilities. And each one of these personas, if you will need to use different tools. And so you can see here just kind of an overview of the types of capabilities that might align to the various constituent parties in an analytics solution. So you have data engineers that are more focused on how do I acquire the data, how do I normalize it into a set format, load it, transform it. You got data scientists that are more about, hey, how do I take the source of data and discover insights with it, train a machine learning model and do that in a repetitive process. Data analysts that also work on the data warehouse, but more probably on a consumption end than a data loading end, like a data engineer might. And then all the way down at the far end of this, you've got the data citizens. They're more like the business analysts that want to connect to the data, consume, and gain insights out of the data. So needless to say, Fabric's got all these personas covered via the different capabilities that we have listed here at the bottom. And we'll dig into some of these experiences a little bit later when we get into the demos. All right, so looking at Fabric as the center of gravity, the big thing to think about here is it's really backed by this notion of OneLake. OneLake is that central landing location. I talked a little bit earlier about the fact that you can have multiple engines work on the same set of data without having to move it to intermediate storage. That's a key concept that goes underneath it here. So the data is all managed within the OneLake environment. However, there's a couple other interesting things in here that I think we need to talk about. One piece of this is the two pieces are really these things on the right. So multi-cloud shortcuts. So we realize that as much as we'd like to be the center of the universe for data, customers and partners have homogeneous environments, right? or not homogeneous, that's the opposite of homogeneous, I'm losing the word here, but the idea is they have environments that are heterogeneous, there you go. And so you've got, you might have data in a transactional database. That's where database mirroring or database mounting comes in. The idea that you can point at an external database, mount the data or mirror the data from that database and have it flow through into the environment. Multi-cloud shortcuts. If you've got a hybrid environment that's got a combination of AWS data or GCP data and also OneLake, you can mount those external data sources without having to constantly, continuously copy that data over there. It's visible and available to Fabric when it needs it, but it doesn't require you to preload and move that data into Fabric in order to make it work. And obviously, Data Factory is a big part of getting data into this centralized OneLake environment. But as we talked about, there are Microsoft managed data sources as well that you can just mount. Things like pointing at the Dataverse is just an additional data source you can point at. You can query things like the M365 graph as well. I mentioned multi-cloud shortcuts. This is kind of what this looks like. So you can have like Azure data sources that might be living in other blob data sources without moving it into OneLake, and this just shows up like another folder in your OneLake lake environment, but it leaves the data where it originally resided without copying it, and that works with AWS and GCP as well. And then, we talked about database mounting here as well, the idea that you can build connections to source database systems like MySQL and Postgres and the like. And then this is the thing that I was talking about there and kind of merging together with the notion of database mounting, the idea that you can point at an external data store and quickly mirror that in OneLake and make it available. And so this is a little bit of a subtle differentiation because, yes, you could point at an external connection via something like an ODBC connector, but you can also do this mirroring concept. And the nice thing about this mirroring concept is as it replicates the data, it's now storing it in that native open format. So it moves it from a proprietary data store into an open format when it moves into OneLake, which is pretty compelling. Now the data, that underlying data store that we use, the Delta Parquet format, that open Delta Parquet format is now visible to all the engines. And so all of the engines can now consume that data in their native semantics without having to go figure out how do I custom load this data. All right, so let's pop over to the demo. So before I jump into the demo though, what I wanted to do was give you a couple architecture diagrams. So I'm going to be illustrating two scenarios. One of them is kind of a warehouse-centric scenario that's going to be working off of a database mirror. And so this is what it looks like. So you'll start off with a SQL database. We'll turn on database mirroring, and then that mirroring will enable us to have a centric data or a Fabric-centric data warehouse, and that'll all get enabled simply by turning on database mirroring. And then I'll show how we can consume the data that is in that warehouse via some native query capabilities, and then ultimately expose that for visualizations via Power BI. We'll also have the ability to connect to other data sources and use the data engineering capabilities of Fabric via pipelines to load additional data into that warehouse as well. And then the other scenario I want to show here is a real-time scenario. That real-time scenario, we're going to be working with a simple IoT device that's sending us a telemetry stream, and we'll be able to capture that telemetry stream as a series of events with our Fabric event streams. Inside those event streams, we'll be able to do some data manipulation, build some calculations, and then ultimately issue queries against that data stream with Kusto queries, KQL, which is kind of like SQL, but a little bit different. And then we'll also be able to build a real-time data dashboard in Power BI to view that data as well. Okay, so let me pop over to my demo environment here. Now, some of these steps take a little bit of time to set up. And so in the interest of time, I'm going to do a little bit more of the cooking show type of demonstration to show you how we set these things up, but then show you the completed solution at the end. And that's just to save us time watching the donut spin while we're waiting for things to happen. So if I come into a new workspace in Fabric, this should feel familiar to you. Anybody that's used Power BI should be used to this, and you can switch between the Power BI experience and the Fabric experience. When I'm in a workspace in Fabric, I have the ability to create new items in that workspace, and you'll see when I bring up this new item, dashboard, it doesn't know where you're starting from, so it gives you the ability to start from a variety of different areas. You could start in the get data experience, which would be more of like a data engineering experience. You can start in the store data experience. So this might be like, hey, I want to start up a new container. I might want to generate a new lake house or a new empty warehouse or a new event house. And so when you start here, it's going to navigate you to the persona that works best for what you're trying to do. And so in this particular case, if I want to do a mirrored Azure SQL database as my starting point, it's going to take me into this experience where I can choose a SQL database. I can either click to create a new one, or you can see here I've already got a few that I've created. So I can pick one. And when I pick that database, it'll take me through the process of defining this connection. Now, what this is doing now is I've picked that data source. It's enumerating the objects that are in that data source and seeing which ones are available and can be used for synchronization. It's going to take a little bit because it's got to open a connection. It's got to enumerate all the objects. It's got to figure out the schema of all those objects, etc. And since I've already turned mirroring on this database that I've started mirroring, the next thing it's going to do is eventually it'll give me an error and say, hey, you can't mirror this database because it's already mirrored into OneLake. So what I'm going to do is I'm going to switch over to an alternate view here that shows this database once it's already mirrored. If I ever need to change the configuration of that mirrored database, I can always go in here, and this is, instead of me starting that experience, this is the identical where we were before. It's still re-enumerating those tables to see what was out there. The difference is this is part of the mirror that I already have instead of trying to create a new mirror against the same database, so it'll work. And there's not really a lot to see here. Like I said, it's enumerating the tables. It'll show me the list of tables that are being mirrored presently. You can see right now it's looking and seeing what the status and the schema is of each one of these objects. And eventually it'll figure out that they're all mirrored in my database. And if I want, I can go in here and turn off a specific database, for example, like maybe I didn't care about, I don't know, DIM scenario. I could just turn that off. And when I apply those changes, it'll disable the replication on that particular table. It also gives me some helpful benefits here, like it'll show me the schema of the existing table, what the data types are, because a lot of times, you might not remember all the objects in your database, and this gives you the ability to quickly see, oh, is that the right one or the wrong one? Now, when you set up a mirror, originally, it's going to take a little bit of time, especially the larger the database is, it's going to take a little bit of time. But what it's going to do is it's going to go through this process where it basically makes a replica of the schema in the target database, and then it does a bulk load of the initial data at a point in time, and then it will set up the stream where it monitors the change data feed on the database and incrementally moves over new changes as they occur. Now, this database is, I loaded it, but I haven't done any transactions on it since then. So you could see it gives you some insights as the status of the replica, and it'll tell you the last time that particular object was updated. Since I haven't been loading any data in, you can see this was last loaded some point in time yesterday, because that's when I set up this replica for the first time. And you could tell, and it'll also tell you how many rows it's replicated, and you can see product inventory and internet sales are our larger tables. And now that this replica is healthy, running, and up to date, I also have the ability to go into the data warehouse itself and start running some queries against that. So let's pop over here and look at the data warehouse. Okay, so if I want to, I can come up here and do a new SQL query and do basic things like you would do for those of you that know SQL. Select, count. Can't type today, apparently. And run this query, and you'll see it executes the query. It's probably waking up. It doesn't normally take this long. All right, and you can see now we've got a good count of the rows. I also have I also pre-wrote some other queries to just give you an idea of some of the other things you could do instead of you guys watching me bang out SQL. But it's got the full capabilities that you would expect in a SQL engine. Here I'm taking a sum on that of the sales amount on that same table and doing a where clause on a date. Execute this query, you'll see you get results as well. Slightly different, but same results. And then I can get more sophisticated and do things like adding joins and grouping and the like. And you can see this will give us similar results as well. So the point here is that this is a complete SQL engine, right? It gives us the ability to do those things that you would expect to do. But as we mentioned earlier, everything is still backed by the OneLake storage. All right, so now that I've got this data warehouse here, what else can I do with it? Well, as I mentioned earlier, some of the stuff that I can do is come out here and do like a data pipeline on this. And I might want to come out and load some supplemental data that I didn't have in that source data to just kind of augment it. And so I could do things like, do a copy data experience, pick a data source, have some blob storage here, pick a folder from my blob storage. Hopefully I set the security up right here. So this is going out there, it's enumerating a storage container, and I can ultimately come out here and pick a table or pick an object, a CSV file in this particular case, and then choose the destination, which should be my lakehouse here, and load that data. And I'm not going to execute this now, but it takes time. But the idea that you get here is that I've got a bunch of different ways that I can find source data and manipulate that through this workflow. It could be as simple as just a straight copy data. It could require some moving data, manipulation of data, enumerating folders and the like, and all that can be done in the pipeline experience. So let's fast forward and assume that's been done already. And now what I want to do after I've got all the necessary data that I need in my warehouse, I need to build a semantic model on that. And this data warehouse experience has got this great model layout capability that's in it, and so that I can go and build that semantic model. Some of the ways to manage this, because a lot of times you might have a database that's got more stuff in it than you want modeled in your semantic model. You can come in here and say manage the default semantic model, and it'll give you the ability to navigate through the tables and views in your database to choose which ones you want to get included in that semantic model. Why you might use a view? Well, let's say you need to do some data manipulation, like join 3 tables together to flatten the schema. You can do all those things in here and choose which objects. So that could be, like I said, tables or views. Once that's done, now you've got this canvas where you zoom in and navigate my model a little bit, where you can zoom in and you can tell the semantic model what the cardinality is of the relationships between these objects. So in this particular model, I have a hierarchy that's represented as what we call a snowflake schema, which is got a product category, a product subcategory, and a product. And so these 3 tables define my product hierarchy, and then they relate back to my sales table. I also have a list of my customers, but the geography data for those customers, meaning what city, state, zip code, et cetera, they live in, is actually housed in an external table as well. So you can see I've got a geography table that relates to my customer table that relates to my sales. And then I have a date table here, which is representing my fiscal hierarchy that's got multiple relationships back to this table. And then I've got some other tables out here as well, like sales promotions and the like. And so I've got a lightweight but complete semantic model that I can use now for reporting purposes. So let me switch over and look at what this looks like in Power BI now. So I could come out to the semantic model, that's this object that I've got right here, and just say I want to do a new report, create a report, and it's going to take me right into an experience where I can drag and drop and do things like we got fact internet sales. I'll show you a couple things. I could say sales amount, and I could say I want to look at this by product. Oh, not product. I want the product category. Product category name. Oops. Drag it under the right visual. And then maybe I want a slicer of country, and I could turn this into a slicer, and I could say, and this is obviously a really basic report, but now when I click the slicer, it's going to update the visuals to account for that. Sorry, I don't know if you saw that there, but the report does update when I change this. So like if I pick Germany, you can see. So anyway, really basic report. So you saw that I was able to turn on a database mirror maybe augment that model with a little bit of ETL, build a semantic model on this, and get to report in a pretty short amount of time. Now, the next thing that is interesting here is, building Power BI is a very, very powerful canvas for building reports. But let's say you're not sure what you don't know what you don't know about the model, and you want to enable some advanced features. So this is where Copilot comes in. So I could come in here and do things like suggest content for a new report page. And it's given me a few suggestions. It's been able to read the metadata of the data model and find those relationships and say, oh, well, here's some interesting things that you might want to do out of this. So like customer demographics. And so I could say, yeah, create a page for customer demographics. And what it's going to do is it's going to look at the model and try and build me something that it thinks is compelling from a customer demographic perspective. I'm just closing some of these down to give us a little bit more screen real estate. And you can see it quickly built a report based on what it was able to glean and read from the customer demographics information. You could see it gave us a bubble chart that shows kind of the heat map of where our sales are occurring. And so like I might want to gravitate in here on California and see, yes, or Phoenix, for example. Let's say Phoenix. Let me see what sales happening in Phoenix. And now I could see some insights about the sales that happened in Phoenix. It also found that we had some gender demographic information. So maybe I want to look and see, are there any interesting patterns about females buying bikes? And so you could see that they represent 49% of our sales, et cetera. And so I didn't have to do anything to create this other than say, give me this. Now, if I decide that this is not exactly what I wanted and I wanted to add some more information here, I still have the ability to take this and augment it, maybe add some more customer demographic information. Maybe I care about education and I care about how the sales aligns to education, and I want to choose maybe a waterfall visual on this one. And you can see really quickly I've been able to take this report that Copilot created for me and then extend it by adding additional capabilities to that. So really, really great productivity accelerator. The other thing that's nice about this is you can ask it additional questions as well. So not only do you make it build reports for you, but you can ask it to do like, give me demographic insights. And it will, explore the model and then give you some insights about interesting things that it's discovering about the model. So not only is it enabling you as a productivity aid, it's also enabling like kind of a chat with your data style experience as well. And this is just a taste of what Copilot can do. We're using it specifically here in the report authoring and the report understanding experience, but is also weaved throughout other areas of the Fabric experience as well. So I could use it to go into a Spark notebook and have it help me write data transformations in a Spark notebook. Or I could go into my model editing experience and have it help me build custom calculations, among other things. And apparently I asked it a question that it has to churn on a little bit more. So anyway, what I wanted to end here with on that particular model is just showing that this is a really easy to get started end-to-end experience. Starting from that database mirror all the way through to reporting, you can see it didn't take very much time. And I will tell you that most of what I did in there was clicking through configuration steps, not actually writing code. And so I feel like this is one of the ways to get from like data to value as quick as you possibly can in Fabric. Now, the other scenarios that I was going to switch over to here was that real-time scenario. And instead of waiting for this to give me an answer, I'm going to, in the interest of time, I'm going to move forward. So I have an environment here, and I'm going to see if I can pull up a couple gadgets and show you. So I have a little Raspberry Pi here that's sitting on my desktop that is running a little bit of code. It's a little bit of Python code that is reading data from a device that I have that's sitting in a glass of water. Let's see, it's going to drip all over my desk now. You can see it dripping. And what it's doing is it's measuring the fluid density of the water, and it's measuring the temperature of the water. And what I'm going to do, try to game the system here, is I've built this end-to-end system, and I'm showing you like the end dashboard on it right now that's giving me real-time insights about both the density and the temperature of my water. And I have a cup full of ice here to just kind of try and game it here. I filled it up with hot water this morning. You can see it's been slowly cooling all day. I'm going to just try and change the temperature of the water really fast here. And Now that I've done that, I'm going to go back through and show you how I built this system. And the reason I'm going to go back and show you is I have the environment right now sent to aggregate the data once per minute, and I know it's going to take a little bit for that data to flow through the system. All right, so let's go back in and look at this environment. So what I started with, whereas before you saw I started with a mirrored database, what I started with in this particular situation was an event stream. And what is an event stream? We talked a little bit about this earlier. Instead of doing batch copying of data, you're tapping to a stream of events that are flowing in your system, and you're running logic over type of those events, and then landing the results of that logic in a destination data store, in this case, which is the Kusto environment. I'm going to zoom in a little here to see so you can see what I'm doing. So I have a source database here, or source data stream here, which happens to be an IoT hub. You know, when I mentioned earlier that I have this Raspberry Pi device, what it is doing is it's reading from my sensor off of Bluetooth Low Energy, and it's basically taking those events and then sending them to IoT Hub as they occur. And what's happening here, as you can see, it's giving me kind of a preview of the last events for a period of time, just so I can see what the structure of the data looks like. And you can see there's some data that's here on it, but there's this raw, I don't know how well this comes across, you can see this raw IoT Hub message that's got a bunch of information in it. And what I've done is I've gone through a process to extract the fields in this data stream that I care about. And then I've created this aggregation window on it. And so what I've told it is, I want you to, every 1 minute, take an average of these values. And the reason I wanted an average of these values is to kind of smooth out the erratic nature of the sensor, where, you know, it might spit an outlier every 100th reading or something like that. And I want that average to kind of just smooth out those outliers to give me cleaner charts. And then ultimately, I write that data to the event house. So what this enables now, let me pop over to the event house view, is now I can see that I've got this event house, and it can tell me and give me some insights about like how much data I'm receiving over time, how many queries have been run against that data set, and you can see this hasn't been running very long. And then it's showing me some information about the health of the ingestion stream, how many rows I've processed today, how much data does this equal on disk, to just help give you some insights about, you know, the size and the performance requirements of your system. And it also gives me the data, the ability to come in here and look at the underlying tables, see the schema of the table, you know, kind of browse the events in there. And then ultimately, I can also come in and run queries against this. And I'm opening a query set. Now, what I'm using here is the language that this real-time data is a little bit different than SQL. It's called Kusto, and it's selecting similar things, but instead of the SQL semantics where you say these are the columns I want and these are the objects I want it from, and by the way, here's the filter criteria, I like to think it works kind of backwards. I say, what's the object I'm selecting? What's the filter criteria I want? And then what are the output columns that I care about? And so the where is the filter statement, and the project is the output statement. So similar, but not exactly the same. And so if I look here, you know, this is going to give me just a straight up list of the events that have happened today. And you could see this is in UTC time, which is why the events look like they happened later than it is right now. And you can see the readings that I've gotten at those different times. I can also do more sophisticated queries. And you can see here I'm doing some calculation and aggregations and like, I was playing around this morning. And you can see this is giving me a single row where I've looked for, you know, an aggregate of some values on the field. And then you can see I can do other things too, like take a max. And so this is just giving me basically the most recent event. This is like a top row. But all these are just different views of that data that is then enabled in my Power BI model. And so if I go over to, oops, wrong tab. If I go back over to my Power BI model now, I can look at, oh, shoot. my tab is getting in the way. I picked the wrong tab again. All right. So if I go back over to my Power BI model now, you could see that this is that same report. And apparently I have a lag in my event stream because it's not updated. I was really hoping that it would have fallen into the floor. There you go. I think the page refresh just died. And so you can see now it's obviously the temperature fell off really quickly. It probably got really close to an ice cube and then got a warm spot in the water and then fell off again. But the point here is that this dashboard is now set up to refresh every 1 minute that aligns with that same data stream. And so that's kind of the punchline here, is just that, we can build very compelling real-time dashboards as well. Obviously these are different scenarios. The first scenario is a very batch-oriented scenario where you're getting batches of data and you're wanting to build aggregated analytics over them and a snapshot, whereas this is more of a, hey, I want a view that is going to give me a real-time feed of that data that's going to dynamically update as the data changes to kind of reflect the current state of affairs. And so slightly different problems. One is more of a real-time telemetry stream, where the other one is like, I want to look at aggregate data over a period of time. And with that has hit the end of my demo. Hopefully I didn't talk past my time window, but I guess I'll hand it back to you, Brian, to
let me ask you a couple of questions if I could. So this is a cool
sure.
demo. I really like it. I like seeing the ice cube drop and seeing the data come in.
Yeah, I wish it refreshed live.
Yeah. So the fun thing about doing live demos, right? But it's
for sure.
Good. So you've got a lot of this aggregation happening in the event stream. So would you say that the event streams is essentially like Azure Stream Analytics in Fabric, right? Is that how you would classify it?
Yeah, that's exactly. If you have any history with Azure Stream Analytics, even the semantics in Azure Stream Analytics will come through here. For example, when you're dealing with a data stream, right, it's got to hold a piece of data in memory, right? And so you have to tell it how much data does it need to hold in memory? And there's a lot of semantics in Stream Analytics that allow you to do that. And one of this is grouping windows. So as you can see in this case, I've defined a tumbling window. What a tumbling window means is like every minute it's going to output a new value. So I could say I have a 1 minute tumbling window. Well, there's also like hopping windows and overlapping windows, and there's a few different semantics that have slightly different characteristics. And so that's exactly what I've done here. The difference is that in Stream Analytics before, it was a very SQL-like syntax, but you had to write the commands to tell it what to do. Well, what we've done here is made this a lot easier with kind of these visual design experience, so a visual query experience, if you will. But you're absolutely right. This is essentially Stream Analytics.
You could take it at any point and branch, right? So if you wanted to get the data before aggregation and say dump it into a lakehouse just for historical reference, you could do that, right? Yeah.
Yep. I could add another output if I wanted. It's running right now, so I'd have to go into edit mode on it. But yes, you could take this. You could join in like another really common pattern in these types of solutions is you have some static data and some streaming data. So like, for example, let's say I had 100 devices and all I had from the device was the device ID, but I wanted to know where that device was located, maybe some characteristics of the device. That's metadata. I could also bring that and join it into the live stream. So join static data to live data. So you could join data or fork data and write it out to multiple positions in this event stream as well.
Very cool. Neat stuff. Excellent. Thanks, Chris.
Cool. Well, yeah, I'm happy to field other questions too. I know I took kind of a lightning fast path through that, but that is the end of my demos, and hopefully you guys found that interesting.
Yeah, for sure. Thank you. I will take control back as we wrap up. But real-time analytics, that's one of the I find coolest areas within Fabric, just because some of the things that you could do. So it's really exciting to see that. And I think also I was going to say we're seeing a ton of interest around it, specifically because analytics for the longest time has been batch oriented, or what are called near real time, where it wasn't necessarily like daily or weekly batches. You might do smaller windows, but there was still some sort of latency implied by the fact that you were processing data in small batches. And we've seen a lot of interest around partners saying, well, I have a fairly active data source and I want
I want to be able to process that data in a real time way.
Yes, exactly. Now, all this is in KQL, which has been rebranded to Event House, I suppose, just to kind of keep the naming more consistent with Lakehouse and Warehouse and all of that. One of the things that I found particularly interesting, it wasn't this way when Kusto was first introduced into Fabric. It was still very similar to what you would get in Azure Log Analytics and then also Azure Data Explorer in terms of a database, meaning it was largely read-only. But fairly recently, that was changed to where they allow the underlying data in an Event House or KQL database to be updatable. You could, kind of insert wherever you want. You can update rows, you could delete rows, which suddenly makes it a real possibility to have transactional data and even build like a medallion-like architecture or something else on top of it, right? It opens up a lot of possibilities.
Yep, for sure.
So very cool, yeah.
Hey, Chris, we do have a question from the chat that I think only you can answer. Basically, the data streaming from the RPI or Raspberry Pi directly to Fabric, is it using some sort of data gateway, or is there some sort of intermediate sync for that connectivity?
Right. So what I've got is I have an IoT hub that is in Fabric, and my Raspberry Pi device has actually got a Python script that's running on it that's basically reading. It's to get way too far into the details. It's communicating via Bluetooth Low Energy, and so what happens is that Raspberry Pi device is using this Python script to connect to that Bluetooth device and read the messages off of that device, and then sends them to IoT Hub. And so the IoT Hub is effectively like our event sync, and the event stream feature in Fabric is what's reading off of that real time.
And there's a Python package to bring that in, right? So you could basically, you've got the glue that reads the event information, but then you have the Python package that can automate the task using the consumer group and the credentials to talk to the IoT Hub.
Yeah, and the code that I had to write here was the code was how to read the Bluetooth Low Energy stream. So I had to figure out how to do that. But once I figured out how to do that, everything else was pretty much turnkey.
Excellent. Thanks, Chris.
Thanks for watching our session. Our calls to action for our partners: join our Fabric partner community on Teams. The Fabric engineering team hosts regular calls on technical topics as well as AMAs with our leadership team. And the Teams channel provides a great way for you to participate in ongoing discussion and ask any questions that you might have. And while we hope to see you in one of our hands-on workshops, we also have lots of learning opportunities in our Fabric learning paths, so dozens of hours of content are available to help get you up to speed and keep you updated on the latest enhancements. And finally, if you're interested in hosting your own in-a-day workshops, such as Fabric Analyst in a Day or Real-Time Intelligence in a Day, reach out to us and get started. I'll paste all of these links in the description below. Thanks for watching.